All right, laser geeks, happy Thanksgiving! I'm putting together another short video on preventive maintenance, specifically for laser welding. Just like in MIG welding, your shrouds have to stay clean. In laser welding, the business tube will start to collect deposits from evaporated metal fumes. Those deposits stack up layer by layer until they block the photon path. At that point, instead of heating your target material, the beam starts heating the tube itself. So here's the key. The very first sign of excessive buildup is when the tube begins to heat up instead of the weld zone. This happens much faster when you're welding aluminum. On a full 8-hour shift, depending on your workload, you may need to scrape the tube 3 to 5 times a day to keep it clear. There are many styles of contact tips out there, but I only use one. Honestly, I don't even remember when I installed it on my tube. That's how long it's lasted. If you set your wire stick out correctly and run the setup as intended, tips generally don't wear out. What usually happens is operators melt them, and that's not a tip failure. It's a hardware setup or user error. So the lesson is simple. Correct wire distance and proper setup keep your tips alive. Melting them means something in your configuration is off. The gun tip rides on the filler wire. Since filler wire is constantly replaced, the guide tip itself doesn't wear out. Fusion welding guide tips. These do wear out over time. No wire feed means the tip drags directly on the material's weld line. Slight friction slowly erodes the tip. Natural wear, not operator failure. If you set up your wire distance along with the correct focal point correctly and run everything as intended, the tips will last for a long time. In most cases, what happens is operators melt them. That's not natural wear, it's wrong hardware setup and user failure. None of the manufacturers build strain relief into the wire harness. Fiber optic cables can't be bent in a tight radius. The outer jacket will crack, and eventually, the fiber itself will break. If you're running a Chinese unit, you're lucky. You can buy a new cable, follow the instructions, and replace it yourself. It still costs time and money, but it's doable. With most US-made units, 90% of the time you'll have to ship the whole unit back to the manufacturer for repair. That means long downtime. So here's the rule. Avoid sharp bends when rolling the harness back onto the unit. You need to feel the natural twist and relieve the strain that built up during use. Your laser welder will shut down automatically if shielding gas is absent or pressure drops too low. That's not a malfunction. It's a safety feature. The system protects itself and your work by stopping immediately. Preventive actions. Keep fittings tight and hoses in good condition. Verify flow and pressure before every day. If the machine stops firing mid-weld, don't assume it's broken. Most likely gas pressure is too low. And remember, never aim the beam toward your line set. That's the critical error to avoid. We already covered tube maintenance. The rest of the gun doesn't really need service. It just needs care. Don't drop it. A fall can damage the galvo. On some guns, you can manually align the laser spot. On certain Chinese units, especially HG Tech, alignment is electronic and done through the touchpad. This alignment step is critical. It protects the longevity of your guide tips and keeps the system running true. Keep cordless power tools away from the welding area. A reflected beam won't puncture the casing, but it will melt the plastic. If a stray beam escapes, it can puncture the casing and reach the battery. That can trigger an explosion, and in the worst case, burn down your shop. I've demonstrated this effect with a small battery pack in my videos. Just a few seconds of exposure shows exactly why this is a serious hazard. Forget the YouTube demos where someone fires a laser at a mirror. You're never going to weld a mirror. The most reflective surfaces you'll actually face are polished aluminum and stainless steel. Even though they're polished, they're not true mirrors. The absorption rate is still very high. Yes, they reflect more than other metals, but the bounce back is manageable. You won't see the extreme reflection those videos dramatize. The practical step is simple. Dull the weld line slightly with a scratch pad, or use masking tape to control the scratch area. That reduces reflection and keeps the beam focused where it belongs. Optics care and failure signs. Optics won't erode if you follow the rules, but buildup inside the tube can reflect rays back toward the lenses and damage them. Wrong beam angle engagement can do the same. If you're lucky, the dust lens will catch it. If not, the focus lens will take the hit as well. A simple replacement fixes the issue, and the telltale sign is tube is hotter than usual and loss of welding power. Laser welding always produces a certain noise. If the tone stays constant, same as 5 minutes ago, yesterday, or the day before, everything is fine. If the sound changes, sizzling, popping, or a different pitch, something is wrong. Noise variation is your first warning sign. From that point on, run through the checklist and track down the problem. On IPG photonics light weld units, reflected heat can build up inside the gun assembly. That heat is enough to slightly melt the pogo connector. When the pogo pin dislocates, you lose lockout contacts and the system stops working. Between tips, tube buildup, fiber optics, particle control, gun care, gas pressure, cordless tool safety, reflection management, and optics, I've covered the main failures most of you will come across. Thanks for watching. If you enjoyed the content, please subscribe and give it a thumbs up. I appreciate your support. Got questions? Drop them in the comments. I'll do my best to answer, and if it's a big topic, we might even make a video about it.